There we go. Okay, so 3.1. I should open it on PDF. There we go. And close this one. Okay. So 3.1, paper 3, A2. Welcome to A2. And the first chapter is data representation. We already know that what data representation means. What does it mean? Anybody? Shahzad Aslam, Ahmed, Kashan, Sharushan, Shanze, Ofran, Indwara, Josefa. Anybody? Hello? But this is the sad part. Yeah, say it. Data representation. अगर नहीं आ रहा तो नो कह दो भाई, क्या हो गया?
सर याद नहीं आ रहा.
अच्छा, data representation. I mean, we need to represent data in computers, okay? Either it's like pictures, sound, video, numbers, alphabets. So if you guys remember that in the first chapter in AS, in 1.1, I'm just recalling it, okay? What we used to do, we started with the number system conversions, then we moved towards sounds, images, in which we were doing those vector images and the bitmaps and vectors, and then we moved towards the videos. Okay, how all these kind of things can be represented in terms of computer in form of zeros and ones. So that is the data we talk about in computer. Okay, either it's sound, it's video, it's so and so. So we will going to continue with the same thing, but because we have that amount of knowledge now, ठीक है, इसको याद recall करना है थोड़ा सा, ये important है, वरना चीजें थोड़ी मुश्किल हो जाएंगी. So the difference is here that we will going to, when we talk about number systems, let me have a whiteboard open in front of us. So this will be our whiteboard now. For a time being, hopefully this pandemic situation will end soon. England में तो भाई 15 June से चीजें back to normal हो रही हैं grade 10, 11, 12 के लिए. So probably they will be going back to the school within a month. यहाँ बड़ी uncertainty आएगी. All right. So we were used to convert these kind of numbers. We call them signed integers. मैं number systems की बात कर रहा हूँ. Data representation में in data representation, I'm picking up numbers. Even though there are some other things as well which you can look in the syllabus, but we were talking about the numbers first because we comparatively link ज़्यादा अच्छा होगा ये इसके साथ. So number systems, what we were used to, how to convert a decimal number into its binary equivalent, how to do that if it's a base 10 thing, means if it's decimal, how to convert it into hexadecimal, and so on. Okay, with plus we also did that thing, how to represent negative numbers which have sign, either it's a positive or negative. We used to call them signed, or there was one another name. क्या नाम था भाई? Something like COM, compli, कुछ याद आ रहा? Two's complement. Okay, so there were the two names, signed or twos complement numbers which have sign, either it's a positive or a negative number. तो उसके अंदर फिर हम एक MSB और LSB का कॉन्सेप्ट यूज करते थे, जो मोस्ट सिग्निफिकेंट बिट होती थी वो साइन के तौर पे यूज होती थी. MSB was used to be as a sign bit. So that was the situation, and that's so far the AS part. What is an A2? We comes up with this thing, we call it floating point numbers. Okay, and floating point numbers, what we have, if we have numbers something like this, 37.5, we have to represent decimal portion. Okay, ठीक है भाई? It's all right in Dwara. Are you getting this? What is new in A2? Decimal portion. We have to represent numbers with having a decimal portion in binary. That's the point. Okay. And there's one other thing, what we call as mentees and abscissa. For example, if you have a number like this, and you have something like this representing, let's say +3. Familiar with this kind of things in mathematics? Shahzad, what we used to call this, the power, the abscissa. If I need to resolve this part, 10 raised to power 3, how does this number looks like? Where the decimal portion will move?
It'll move forward.
3 places forward.
Like this?
Yes.
Yeah.
Good. So we also need to represent such things with you know, the power, what we call as abscissa, or the real name is exponent. Okay, so the mentissa, it is this portion, and the exponent. So we have to represent these things in binary as well. So that's the new thing that we will going to do in A2. And also we need to, if we need to, you know, move the decimal portion towards right or left, that thing should be available in binary number systems as well. So in twos complements, in data representation in A2, we will be talking about not only the signed numbers, but also the numbers with the floating point numbers, and including mentees and exponent as well. So that's the target of today's class. And there are lots of some more nitty-gritties, details, how to represent the largest number, how to represent the smallest number, including the exponent in this amount of number of bit registers. All right, so let's have a look on the notes. User-defined data type, we're going to do this later. It's easy, it's fun, file organization and access. This is just the theory part. So we're basically doing the 3.1.3 first. So that's the real numbers and the normalized floating point representation. Real numbers are basically numbers having decimal portion, okay? The real data type, if you remember. Let's do it. If we have a look on notes, these are the classes, file organization, all theory, all fun. So the real fun begins from here, okay? So there, if you will be revising the whole lecture, you can also revise through the notes that there are some examples given. Which is what the thing that I was telling you, it was like similar is being told here. So how you can represent a number 2.6 0.25. So that's the thing. Okay. What we need to do, let's do it in an easy way. For example, just forget about its signed or unsigned. If you have a number like this, let's put it 75. And if I ask you to convert this decimal number into its binary equivalent, तो सबसे पहले क्या करोगे? You start making this series. You remember that? शानज़ा बेटा आवाज आ रही है आपको? Can you hear us?
So you can just also divide that number by 2.
Yeah. So
That's
now
it.
you can
Nothing.
make 75. Yes, Indwara?
No, nothing. So,
Yeah. So this is how you can convert 75 like 64. The 0 will come here, and this is 32. Will make a larger number, 64, and this will make 72, and this will make 74 and 75. You got it? You're a bit used to it. But what you have a number like this, how to convert this number? Okay. So this side, it will be taken care in a similar fashion. Sorry. This side. It will be taken care of in a similar fashion. Like this. All right. And how to take care of this part? 0.25. Just like we know that, now this is a crucial point. Just like we know that the power goes like this, one, it doubles every time, 1, 2, 4, 8, 16, 32, 64, 128, when we move from right to left. Okay. If we have a decimal portion, then the powers will be halved every time at the other side. For example, if there is a decimal portion here, the power is starting like this. It will be like 1 upon 2, 1 upon 4, 1 upon 8, 1 upon 16, 1 upon 32. In our syllabus in A2, we have to remember powers up to this, upon 1 upon 32. It's 1 upon 2 is like 0.25. Sorry, 0.5. You know that. This is 0.25. This will be 0.125. All right. This will be 0.0625, and this will be 0.03125. It's really cool. It's important. It's best if you can remember this. And you have to remember up to this level. That's it for our syllabus. Okay. So you need to make this 75.25. You already have your 75 here. There goes the decimal portion. 0.25. Now you need to have 0.25, and there goes your 0.25. Yes, you can always include zeros if you feel like, but these and these zeros doesn't matter. So your answer will be something like this: 1001011.01. So this is your 75.25. Easy peasy. Are you guys getting it? Any questions so far? Any problems? Let me hear it from you. One thing that we can do, क्योंकि जरूरी है तुम लोगों को थोड़ा सा जगाने के लिए, कहाँ गए पार्टिसिपेंट्स? सारे पार्टिसिपेंट नजर आ रहे हैं मुझे. You people have switched on your microphones. Why is that? Who muted Sadiq? That's, oh no, no one. Okay. I'm going to give you guys a question and you guys have to solve it. Okay. And how you are going to share it with me? We do have our WhatsApp thingy going on with us, which you can use to submit me the answers with the help of screenshots or the snaps from your smartphones. Okay. So that was a question. And just let me leave this question here. In front of you for your copies. Solve one another question. 14.75. Solve it. Five minutes. I need replies from everyone. Come on. किसी को समझ में नहीं आ रहा मुझसे पूछ सकता. This will going to assure me you all people are present. Okay. Okay, the decimal portion, let me go this once again. इसके बाद मैं क्वेश्चन तुम लोगों को और दे दूंगा. Let's do this in a minute. Meanwhile, if you already know how to do it, बेटा इसको solve कर लो जिन बच्चों को समझ में आ गया. So 14.75. गुफरान, हम इसको जो इस साइड के ऊपर है इसको हम उसी तरह से लेके चलेंगे. 14 को 1, 2, 4, 8. We are used to this pattern, right? 1, 2, 4, 8. The power doubles every time. Decimal portion के अंदर, binary के अंदर जो power है वो हमेशा half होती चली जाती है. 0.5, that is basically 1/2. 0.25, that is basically 1/4, and so on. 0.125 and so on. यहाँ तुम्हें up to 6 decimal portions तक power याद रखनी है. That's important. Okay. So 14, how are you going to make 14? 8, 4, 12 हो गया और ये 14 हो गया. This is your 14. How to make 0.75? And this portion is remained. You need to make 0.75. All right. And for that, 1.5 के अंदर तुम 0.25 ऐड करोगे तो 0.75 हो जाएगा. So this will be your answer. Good. So do it like this. Let me give you another question. Let me pick a little bit difficult one from the past papers. I think we have the answers here. From Kashan, we have the answer. That's good. That was before me completing the answer. That's really good. So one person replied finally. An official reply. ठीक है? ये official reply आ रहा है बच्चों के मेरे पास. Question solve करके दिखा रहा है. अच्छे बच्चे. All right. Jump into the part. This is, we haven't done with the decimal portion yet. The normalization is still there. It's a thing to do. The exponent thing is still there. You know, you need to take care of that as well. So we're just at the beginning part of it. The past papers. Come on, what happened? This is 0.625. There is another way of doing this. Guys, there is another way of solving that decimal portion. But the thing that I've just told you right here before, uh, it's this method. This is even comparatively more simple and faster way to solve it. Okay. So yes, we can solve it this way as well. I can teach you this at any other time. That's even it's fun. But this one is recommended as per the exam, point of view. So let's try to stick to that. Convert this. You can convert it in this way. We have 14.7. So you can convert it in some another way. 111. अच्छा इस तरह के क्वेश्चन पास पेपर्स में नहीं आएंगे 0.7 वाला क्वेश्चन नहीं आएगा क्योंकि the 7 you cannot represent 7 under those 6 fractional points. This is important. I'm just repeating myself. 14.7 type of questions won't come in examination. You can definitely solve this way. It is because in computers you cannot actually represent 0.7. This is one of the lacking of digital systems because you have a fixed fractional like 0.5, 0.25, 0.125. So 0.7 cannot, if you can remember that sometime and you just, solve some questions, you get the answers like 6.33333333 in calculators, okay? It's not precisely mentioned. It has some, lacking in between of it. So that's the reason. ये 14.7 वाले क्वेश्चंस आपको पेपर के अंदर नहीं आएंगे क्योंकि वो आपके फ्रैक्शनल पॉइंट के अंदर कंप्लीटली लाई नहीं करता, एड अप करने से बनते नहीं है. खैर ये प्रैक्टिस से चीज आप और सीख जाओगे. Normalization part is talking about normalization. We should have more past paper questions here. These are the user-defined data types. They're really super fun. File organization सिर्फ रटा. और यहाँ पे हम एक्सपोनेंट्स की बात कर रहे हैं. ऑलराइट 0.75 का तो तुम्हें ऑलरेडी आइडिया हो ही गया होगा. चलें मैं चाह रहा था नॉर्मलाइजेशन में जाने से पहले हम कुछ क्वेश्चंस और सॉल्व कर लें. 3.5 is piece of cake. You guys can easily do it. Plus 0.25. चलें जी इसको सॉल्व करके दिखा दें. ऐसे सारे बच्चों को पता चल जाएगा कि सबको समझ में आ रहा है नहीं आ रहा. ठीक है. Forget about the normalization part. Okay. ये हम अभी नहीं करें. Just convert 3.5 for me. The positive one. Okay. And meanwhile, we move to the normalization after that. कितनी मेहनत से जवाब दिया अनस ने आज. अनस स्क्रीनशॉट लेके भेजे थे मुझे तो. ठीक है. शहजाद इज करेक्ट. सब बच्चों को अब तो सारी जवाब दे देंगे. अनस की तरह इंडिविजुअल मैसेज भेजो ना अगर जवाब देना तो. नहीं सही है. Just use the group. Forget about the individual messages because we can, maybe use this as a record as well. Use our main group. CS.
So what do we have to do?
Yeah.
What do we have to do?
You just have to convert this 3.5 and show me the answers, just like people are doing it. Look, you just need to convert it now. I just want to have an idea that you know how to take care of it. We are not doing normalization right now, so don't look into the marking scheme. 3, we have a decimal portion 1248, 0.5, 0.25, 0.125, 0.0625. I'm doing this so you people can also remember it. And 0.03125. So we need to make only 3.5. This is our 3. This is our 0.5. This is the answer. All right.
So don't we have to show the zeros?
You don't need to show the zeros, of course, because showing zeros at this side, showing zeros at this side won't make change in any value of this, the width of the weight of this number. It will remain same. You know this, now?
Yeah. I do.
So this is how it is. Sharushan replied. Sharushan, it's good that you people reply on the same group. Your answer is correct. Ofran answer is also correct. Anna's answer is also perfect. Guys, reply on the same group. So we're going to have a record now. So you people are replying. All the students are replying there. Okay. Let's move towards the next topic. Okay. Before moving towards the next topic, I guess I should tell you about the second method that we were talking here. So there shall be no confusion remained. For example, there's a number 2.625. Okay. So how to represent 2.625? The method that they have used here. Okay. 2.625. We already know how to represent 2. It's 1248. So the 2 will be 10. And how to convert 0.625. The method that has been shown here, you multiply this 0.625, the remaining portion, with 2 every time. Once you multiply this with 2, you get the answer something like this. Okay, if it's like 1 point something, you take the 1 and you multiply rest of the portion with 2 again here. So 0.25. Again multiplied with 2, the answer is 0.5. You take this part here and you multiply the remaining portion 0.25 with 2 again. And you keep doing this until you get the answer something like this, 1.0. If you get 1.0, you will not going to divide it further. Sorry, you will not going to multiply with 2 further. So 1.0, you take the 1 and you end the score, because ab yahan pe 0 aa gaya na. If you're going to multiply a 0 with anything, it will again, becomes 0. So your answer for 0.625 will be 101. So you can also have your answer something like this. So you have your 2.625 like this, 101. Now let's try to solve the same thing using our method. That was something like this. We have a decimal portion 1248, power is halves every time here. It's like 0.5, 0.25, 0.125. Okay. By looking at it, if you add 0.5 with 0.125, you will get 0.625. Do you? So you switch on this, you switch on this, your 0 goes there, and this is your 2.65. So now we know both of the methods. This is our method. This is also the method that's been introduced lately, and you can do something like that. Okay, The benefit of this method is what if you have some number like this? This can be solved. Yeah, something like that. 0.7. In 0.7, what you can notice here, you multiply it with 2, you got 1.4. Then you just multiply this 0.4 with 2, 0.8. It continues. It's not ending. It's repeating itself again and again. Look, it's again coming up to this position. 0.4, this 0.8, this 1.6. So if something like this is happening, it means it's never ending. It will continue. You have to show up to some certain amount of fractional point numbers. So you just leave after 6. So and again, I'm just repeating myself. This is really important. This is one of the drawbacks of digital fractional point numbers. I may have quoted one example there in my notes. That's back in regarding some SCADA missiles. The US military response system. For example, they also used to call Patriot missile batteries. When somebody have actually fired a missile towards your state and the target has been locked down, you can fire another missile from your side, which can hit that missile and destroy it into the air. So that is the one of the very awesome defense system by US, which was given to Saudi Arabia back in 90s. I don't know the exact date. I guess it's 1992. And it was definitely controlled by the computers, calculated. And no, this is not a missile, man. And what happened actually, because their computers couldn't calculate the exact fractional point numbers, the locations. So there was one incident, there were some missiles fired by Iraq towards Saudi Arabia, and SCADA, the response defense system, missile defense system of US, deployed in Saudi Arabia. It couldn't respond properly, and the missiles from Iraq actually, got hit in KSA, and the KSA, the Kingdom of Saudi Arabia, they were like all angry, like why the US defense missile defense system is not working and all that. So the real thing was, because in digital numbers you cannot represent exact fractional point numbers. So that was a drawback. Later there were some more algorithms to solve that issue. That is one of the drawback of digital number systems, including fractional points, that you cannot exactly pinpoint the value, because it goes like this: 0.5, 0.25, 0.125. How you can represent 0.3? So it's like 0.33333333 like this. Okay. Hopefully you got my this small little lecture, what I'm trying to say. Let's move on. Could I have mentioned this thing here? Normalize. This should be something I've talked about. Real numbers, 5. This like 7.10, 1.3, keep repeating itself. Okay, normalization. Mentees and exponent. The concept of mentees and exponent. So for example, we already have an idea here. If you have something like this, if exponent is minus, so you already know if you will going to solve it, it will become something like this. All right. How to represent this thing in binary. So that's the task. So we use two portion. We say this whole thing. Sorry. Yeah. This whole thing is known as mantissa. And this portion is known as exponent. Often in computer science, in our syllabus, you will hear that they're going to give exact some number of bits, let's say a register, an 8-bit register for mantissa, and 4-bit or maybe an 8-bit register to represent exponent for exponent. Because you also know how to represent signed numbers, please let me know that you know it because we have to revise it then. In negative numbers, when we represent negative numbers, always the MSB, it is used to represent sign, or it has a power which is minus. For example, if you have this 8-bit register, it goes something like this. Minus 128. Okay. And similar thing goes for the exponent as well. If we want to represent the exponent, it's 2, it's 4, it's 8, it's whatever. It goes like that. Because exponent can also be, you know, it's negative, or it could be a positive one. So it can have this thing as well. So this is important. All right. So the mantissa and exponent, how to represent them. Now this 37.625, you people already know this, how to convert it. 1, 2, 4, 8, 16, 32. So 1, and it will be
4 1.
4 and 1. And 6 to 5. 6 to 5 will be 101. This is the whole number. 1, 2, 3, 4, 5, 6, 7, 8, 9. This 8-bit register is smaller than that. So somehow let us pick some another number from the past papers and let's try to solve that. Because right now I cannot represent this number here. It's just a bigger number. And then there is a concept of decimal portion as well. Unless you want to say something, you just raise your hand. Any questions? Guys, it's good if you guys have the microphone with you. Nahi? Khair, okay. Okay. So let's move on to that portion. All right. So the concept of mantissa, the concept of exponent, if the values is given in registers, how to show it, and if the number is given in decimal, how to represent it into registers in a binary form. You need to know both of the things, and then there's a concept of normalization as well. Let's improvise. Let's try to solve it through the past papers. Peter, this is the question, and
So I got 2.5.
you got 2.5.
Yeah.
Can you show us the working on WhatsApp?
Yeah. Just a second.
अनस तुम्हारी पिटाई होने वाली है. अच्छा, alright, खैर हो गया. Mantissa is positive, exponent is positive, even though they have mentioned it's a 2's complement. We know that the decimal portion is there. Exponent is 1, 2, 4, 8, 16, 32 is not required because it's plus 3. Why it's plus 3? Because it's 0. And just rewrite it. Plus 3 means it will become, yeah, so 0.5 and 1, 2. This will be 2.5. Very good. Plus 2.5. I hope everybody gets the answer. Shows is the answer. So this is a mantissa and exponent having all positive mantissa and positive exponent. Yes, Induara, you want to say something?
No, sorry, I accidentally pressed it.
Okay. So you have to have a close look. If mantissa is positive, exponent is positive. If mantissa is positive, exponent is negative. Even this can happen. Your mantissa is positive and your exponent having a negative value. It's mean that you have to move the decimal portion towards some other direction. So this is the thing that you need to take care of. We will going to have all the different kind of questions hopefully. If we will going to have some time, but still I'll recommend that we do normalization in next class, so you can have this enough. Okay. The largest positive number that can be written as a normalized floating point number. ये हमारा last topic होगा 3.1.3 के अंदर. और ये चीज हम already
सर वो
define
वाली एग्जांपल वापस दिखा सकते हैं जिसमें 17 आ रहा था.
शेष वाली एग्जांपल हमें करनी पड़ेगी जल्दी से. कर लें क्या? I guess this is the one. Yeah, this is the one, right? तुमने इसको लिखा नहीं?
मैं बीच में लिख रहा था लेकिन
It's okay.
कुछ गलत कॉपी कर लिया मैंने. गलत आ रहा है आंसर मेरा.
2's complement है. By looking at MSB, we know that it's a negative number. Exponent, it's all positive. It's a plus exponent, 1248. It's plus 5, okay? Because the mantissa is negative, you need to take 1's and 2's complement because it's a negative number. Because it's a negative number, okay? So how you take 1's complement, you flip every bit. You write it like this. After flipping every bit, hopefully I'm not making a mistake. 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. Okay. After flipping the bit, in 2's complement, you add 1 at LSB. 1, 1 becomes 0. 1 will be carry. It will come here and your answer will become like this. We always know that the decimal portion resides there. Okay, it's by default. Now we apply the exponent. It's plus 5. 1, 2, 3, 4, 5. So it will become like 0, 1, 0, 0, 0, 1.1, 0, 0, 1, 1, 0. So this is 1, 2, 4, 8, 16, 32. 16 plus 1 becomes 17. Decimal portion goes there. This is your 0.5. This is your 0.25, 0.125, 0.0625. And this is your 0.03125. अगर आप भूल भी जाएं तो खैर कैलकुलेटर तो अलाउ नहीं होगा. Because calculator is not allowed in such questions, that is the reason I'm asking you to remember these things by heart. 0.5, 0.25, 0.125, and so on. Up to 6 decimal portions, that's it. So by adding these all up, what was the answer? If anybody can let me know. 17 point. Something like 5.
17.59375.
0 point.
17.59375.
59375.
75.
Okay. And in last, you must, to get the full marks, you need to remember that it's a negative number because it has 1 there. So this is your complete answer. Now you get it, Kashan?
जी sir, thank you.
Yeah, it's just important that if you just write down the answer in front so you can, or you can also make your bullet points as well in your copies. For example, if Mentisa is negative, you first have to take 1s and 2s complement, and then you have to resolve the exponent. Now this is the important part, okay? If Mentisa is negative, you first have to take 1s and 2s complement, then apply the exponent, and after solving the whole question, put down the minus sign. So these things are important. ठीक है भाई? Okay. Let me find some more questions. At least you people should get this 3.1, and if there will be one more booklet needed, because our online classes are being continued for a couple of months, right? For 6 weeks at least. So grab this 3.1. I'll ask Sir Asif. You can go one by one if this facility is available, and you can grab your printed copies from there, so you can solve them first hand in your copies. This one is easy. If we can find one with the negative Mentisa, that would be fun. Look, the decimal portion is like always there. In a particular computer, हाँ इसको normalize करना पड़ेगा क्योंकि decimal portion उस तरफ जाएगा. इसको normalization करने के बाद करेंगे. इसके लिए भी normalization चाहिए होगी. Yeah, normalization is. Most of the questions are so easy. Most of the questions are easy. Look, they're fun to solve. All right. Normalize way में करना. मुझे लगता है normalization बतानी पड़ेगी तुम लोगों को. अभी बतानी पड़ेगी. Significant. Okay. In a particular computer system, real numbers are stored using floating point representation. This question is October-November 16. Calculate the floating point representation of plus 3.5 in the system. Show your working. Okay, now they have just told us to solve 3.5. 3.5 is just the Mentisa. but they have given us the register for exponent as well. Exponent will be required later because 3.5 will need it to be, normalized some way. Now, how it will be done, let's try to find it out. What this normalization is basically, and why it's required so much in digital real numbers in computers. All guys are with me? Because we're going for one big concept, the normalization, in one go. All right. So if we just go with 3.5, we know that it's something like this. 1, 1, and 1. I guess you guys are pretty smart now. You just even don't need to, 0.5. This is your 3.5, right? Isn't it? It is.
Yes.
It is your 3.5. Now, you cannot put 3.5 here because it's 1 point. You have to have a decimal portion somewhere at some other place, because it's a positive 3.5. I cannot write it like this. I cannot even write it like this because it's a positive 3.5, and positive must have a 0 here before in 2's complement. You know that, right? It must be like this. To represent this 1.1, now we need to normalize. Normalize means we need to make it into a form so we can store it here in this Menti cell. Plus 3.5. So you need to move the decimal portion here like this and like this. It means that you need to take the decimal portion towards left. And when you do that, exponent, like it will be added up like this, +1, +2. This is just like your basic maths. For example, if you have a number, like for example, if you have 57.0, and you know that you can write it like this, 0.57 multiply by, am I right? You can also do this, guys.
Yes, sir.
All right. So it's mean if you were going to move the decimal portion towards left, the power will be added up. If it would be like this, it will be like this, isn't it? Okay. So the similar thing that we need to do here is we need to move the decimal portion here. So once you're going to do this, it will become like this. And the exponent, now it's the base 2, we're not going to write down 10. The base will be, you can also write it down like this, 1, 0. 1, 0 means 2. Or you can also write it down like this. In a binary form, you can just do something like this. This 1, 0 means 2. I'll just put it. All right. So it's a positive exponent.
So I didn't get that to the power 2 part.
You did get this part?
Yeah, that part.
Okay. Did you get this part? Why I have done this?
Yeah.
It is because I need to represent a positive 3.5 here. And I have to have a 0 here. I have to have a 0 because it's a positive number.
Yeah.
Okay. So that's the reason that I have to move the decimal portions 2 steps towards left. When you move a decimal portion towards left, every time you move one decimal portion, it's like +1. Another decimal portion, it's +2. So exponent becomes 2. Exponent is 2.
Oh yeah.
All right, you get it?
Yeah. Yeah.
Okay. So this is the reason your exponent is +2. Let me have some questions from the chat as well. Okay. Okay, Sadek. All right. So after doing this, now you can write down your exponent. Exponent is 2. There goes your exponent. And there goes your mantissa. So this is what the importance of normalization in digital computers, because this is the only way you can represent plus 3.5, because always mantissa in computers and digital systems, whatever the form in whatever form they are being used, they're fixed. You set 8 bits for mantissa, you set 8 bits for exponent, and if you need to represent plus 3.5, they will be represented like this. There is no other way, because decimal portion is like fixed, it's on its position after first bit. So this is your answer. Just let me find another question for you people.
So, sir, the exponent moves by 2, right?
The
Yeah.
exponent,
Not the decimal point moves by 2, right?
yeah, it is.
Yeah. So why do we write 2 to the power 2?
Come again?
Why do we write 2 to the power 2?
Yeah, why we write down 2 raised to power 2? It's because we're dealing with the binary numbers, huh? You cannot write down 10. 10 is for the decimal numbers. This is just a way of representing it. You can just write down, yeah. So this is just letting the examiner know that it's a binary numbers base, and the exponent is 2. And even sometime you know, in books, in notes, you're going to see that they will going write down something like this 10. This 10 is not 10, it's basically binary 10, which you can see here.
Okay.
All right.
Yeah.
This is it. You just let me find another easy normalization question for you. This question is May, June. It's October, November, I guess. Yeah, October, November, 1632. October, November. Okay. The second part of it, find the denary value for the following. That's easy, you people can do it. State whether the floating point number gives an. This is another reason we call it a floating point, because the point floats towards right or towards left, especially during normalization. And in computers, we call it floating point numbers often. Easy one. We need one more question. Yeah, there you go. Try to store this plus 2.5 in mantissa and exponent. It's all over you. Guys, I'm just completing my class today here. That's 3.1.3. We're just almost done with it. The only remaining portion is how to represent the largest and the minimum value. Definitely we need more practice regarding normalization. Yeah, one more thing, how to represent this negative number with the help of normalization here in this register. So most of the things are done. Few of the portions have been left. We're going to complete in next class. This is quite a task. We have done quite enough. Well done. If you have really understood it, please remind me over the group. I'll communicate with the BCCD people if I can, you know, let the hard copy be placed with Sarasaf. Okay. All righty. Any questions so far? This is the last question. You're going to do it and then send me the screenshots over the WhatsApp. Okay. Before this, any questions?
No.
No questions. Okay. Solve this. Send me the screenshots on the group, and I'm just leaving the class. See you tomorrow around 12 p.m. Okay.
Yeah.
Okay. Bye bye.
Bye. Thank you.